Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, my dear students? I hope you are all fine and in a good health. Today, inshallah, we are going to talk about Unit 2, Lesson 1, Fundamental Forces in Nature. What's meant by fundamental means basic forces in nature. What's meant by force? Okay, suppose, for example, if we have a table, we can put above it a book. Okay, could this book move by itself? Of course not. Why? Because there is no force acted on this book. What about if I'm having such a ball under this table? Could it move by itself? Of course not, because there is no force acted on this ball. What about the goalkeeper? Okay, we have a moving ball and we can fix it or stop it by the goalkeeper. So it moves from static or from motion to static, from being moving to the goalkeeper unless it's the goalkeeper stop it already. What about if I'm having another ball and the football player could change its direction by throwing it to another football player? Okay, so from here we could define the meaning of force. Force, it's an effect, okay, that attempted means tend to change the object state. Object state means phase, okay, from being static to motion, from being at rest or stable as the fixed ball or the fixed book above the table, to motion while we are moving it as we push the ball, or vice versa, or the contrary, it could move and stop it, or stop it and then began to move, or attempted bend to change the direction of motion. As we said, the football player could change its direction also. What the measuring unit of force? It's Newton, as we have taken any type of force, its measuring unit is Newton, of course. Okay, we have so many types of force in nature, as what lightning, thunder, magnetic force, as a type of attraction force, okay, due to the presence of a magnet, or even the gravitational force, which known as weight. All of those are types of forces, different types of forces in nature. And we have life application depend on this also. As what? We have nuclear reactor, we have electric energy. Okay, we can produce so many types of energy from force. But for in this lesson, we are going to have 3 fundamental forces in nature, briefly as full details. As what? Gravitational force, number 1, which known as weight, okay, and we have taken it briefly or previously in the 6th grade. Number 2, electromagnetic forces, okay, which comes from the magnet, okay, and we will discuss it later, inshallah. Number 3, nuclear forces, okay, which coming from the nucleus. The first one, okay, the gravitational force. The gravitational force, we know it before by weight, object weight. What about the weight? It's the ability of the Earth to attract the object to its center, okay, or direct to its center. We can calculate the object weight by the relation mass time gravitational force. At the last year we were having, okay, the gravitational force by 10. But for this year, okay, we are going to have, okay, instead of 10, we are going to mention that it's G. G is the force of gravitational force, okay, which approximately 9.8, okay, 9.8 meter per second square, which is approximately 10 as we have taken it before. As we have taken, we can write also the relation W, which refers to the weight, equal mass, M, which refers to the mass, times G. G represents the gravitational force. Weight is measured by, as any type of force, as we have mentioned in the beginning of this session. Weight, its measuring unit is Newton. Okay, Newton is the name of the scientist, or Isaac Newton, who had discovered the weight by falling down of an apple on a tree when it fall on the ground. Okay, he discovered then what's meant by gravitational force. And mass, its measuring unit, will be, of course, kilogram. Gravity, or gravitational force, or acceleration due to gravity, okay, it's equal 9.8 meter per second square, okay, approximately 10. From this relation, we can conclude a magic triangle, okay? The magic triangle, okay, we have weight equal mass time gravitational force, okay? From where we can calculate the relation of the weight here. Weight equal mass time gravitational force. We can get the mass by dividing the weight over gravitational force. Thank you. Okay. After that, we can have a problem on this part. Okay. If in the problem we had mentioned already that the value of the gravitational force is 9.8, so we should put it as 9.8. But if he had mentioned already freely, so you can put it 10 as we have taken before. Here we have a problem, okay, for the gravitational force. The problem said find the weight of an object, okay, of 100 kilograms. So as he mentioned, kilogram, so that's meant mass, because the measuring unit of mass is 100 kilograms. Knowing that the Earth's gravitational acceleration is 9.8. So here he had mentioned already the value of the Earth's gravitational acceleration, which is 9.8 meter per second. So by having the law of the weight equal, yes, you can mention it, mass time G. Okay, the value of mass, as we have mentioned before, 100 times G. Here we couldn't put 10. We should put it as 9.8. So it's 9.8, and the final result will be 980 watts. We should write the measuring unit, of course. What's the measuring unit, as we have mentioned it before, of the weight? Yes, of course, it's Newton. Thank you, excellent. Okay, another type of force, before we can get and talk about another type of force, we can talk about the gravitational force as well. Our Earth, our planet Earth, okay, is not spherical shape, but it's elliptical a little bit, or flattened from the two equators. So it's not spherical, but it's flattened a little bit from the two equators. So here, the more I come closer from the center of the Earth, the more gravitational force, or the more weight I could get. What about the difference between the equator? Here we have that's the equator. And what about the two poles? Here we have a pole, and here we have the other pole. What about the two poles? Of course, due to the unspherical shape of the Earth, there is a difference between the weight or the gravitational force between the equator or the two poles as well. If we have, for example, a person who's standing on the pole, North Pole or even South Pole. So he has attraction force more than a person who's standing on the equator. Why? Because the distance between the equator, okay, completely different than the two poles due to the non-spherical shape of the Earth. So, in case of the pole, the distance between the center of the Earth and the pole, okay, is so much, a little bit than the equator. The equator is so elongated more than the pole, okay? Refers to the second type of force which we are going to talk about. It's electromagnetic force, okay? From its name, okay? Electro, then magnet. We have two types. So it transfers the electric energy, okay, at the first part of the word, electric energy, into magnetic energy. Excellent. How? Okay, always remember, okay, it transfers from electric energy to magnetic energy. How? By using an aid or instrument which is called electromagnet. How it could, like, you have taken it before in the 5th grade. We have something like the electromagnet as this. We have isolated copper wire rotate around the electromagnet from the two sides, okay? And we have here, that's the copper wire. Then I'm going to connect the copper wire with what? Excellent, a battery as a source of electricity. Right, okay? We have, of course, a battery. We are going to connect it as a source of electricity. What about the magnet here? The magnet change by using the electric current or by passing the electric current from a simple type of iron to be what? A magnet. It changed from the simple type of iron into a magnet. How? This shape is not actually a magnet. It's made from wrought iron. What's meant by wrought iron? It's not actually magnet, but it gained magnetism by passing the electric current through it. How? If I come it closer, I make it closer from, okay, a Petri dish filled with iron fillings, okay? Iron fillings, of course, what will happen? The magnet will attract the iron fillings, okay, at its two poles. Why? Because it connected to the battery as a type of electric source or passing the electric current through the magnet. If I disconnect it, again, if I disconnect it here, that's open circuit, so the iron filling will disappear completely, which means that it returns back again to be a simple type of iron. We can use or we can observe this type of magnet in what? At first, we can see it, of course, in the electric winch, okay, which used to lift the heavy, okay, heavy iron blocks, okay. As you know, for example, the car movie, when they trying to move the smashed cars from a place to another, so it connected to electromagnet. When I connect it with from the key, okay, it changed from a simple type of iron to be a magnet. Okay, and attract the heavy blocks or the heavy iron blocks. If I disconnect it, okay, from the key, it returns back again to be a simple type of iron and loses its magnetism. That's the first example, which is the winch. Okay, winch. That's the first example. The second one will be what? Okay, the electric bill, which used in schools, at your home, your houses, there is no problems. Electric bill as well. And where else? The mixer, which your mom used it in the kitchen as well. The mixer depends on the electromagnet. And never to forget that the electromagnet, it's beginning electro, then magnet. So it changed from electric energy to magnetic energy. Okay? That's the first part. It's very important. Okay? The electromagnet change from electric energy to magnetic energy. Comparing to the electromagnet, we have, on the contrary, the dynamo. The dynamo, okay, refers or change from kinetic energy into electric energy. Okay, so the dynamo change from kinetic or mechanical. They have the same meaning. Okay, they have the same meaning, kinetic or mechanical, which changed into electric energy. The dynamo is which produce electric energy. Okay, that's the second type of devices. We should know the transferring of type of electricity or of energy from what to what. Okay, the third type, more than the electromagnet and the dynamo, we have also the motor. So we have here, that's the dynamo. Okay, the motor is the vice versa or the contrary from the dynamo. Why? The motor change from electric energy and change it to mechanical energy or kinetic, because we have mentioned before they have the same meaning. Okay, so don't forget the changing of energy from electric or from kinetic to electric in the dynamo, from electric to kinetic in the motor, from electric to magnetic in the what? Thank you, excellent. In the electromagnet, don't forget it, would you please? It's very, very important. The third type, and the so easy type of force, okay, which we are going to have now, we have the nuclear forces. Okay, when we were talking about the chemical reaction, we were talking about the nucleus, okay, and the energy level as well, and the electrons. Okay, but we never come closer from the nucleus. Now, during the nuclear reaction, okay, we are using the nucleus, okay, which by throwing a body to the nucleus, okay, it generates a huge amount of electricity. Really very, very huge. How we could use this huge amount of electricity in two types. How we could use it, okay, in two types. How? By weak nuclear forces and strong nuclear forces. Do the nuclear forces produce all of these types? Yes, of course. Okay, it produces a huge amount of electricity. The strong one used maybe to generate electricity, to lighting cities and so on. Okay, because it's very huge. Or maybe a massive destruction, as in wars as well. What about the weak nuclear force? The weak nuclear force, we may use it in industry, okay, as expiration date of so many types of food, as in medicine to treat any type of tumors, as cancer, la qadar Allah, okay, unfortunately. Okay, so we may use it in medicine, in industry, and medical research as well. We may have such type of rays, alpha, beta, gamma. You may have it the next year, inshallah. Okay, we can get it with full details. Okay, I hope you understand the lesson. Have a good luck. Study well. Thank you.